Hi everyone, welcome back to the channel of Data Science Journey. Since people watch this to know the concepts, initially I just want to jump onto it and let me explain you the concept of this video is confusion matrix. So why confusion matrix? There are different kind of ML algorithms. We generally build a machine learning model for classification tasks, regression tasks, clustering tasks. We have different algorithms for each and every different use cases. But this confusion matrix is particularly useful when you develop a classification model. So why confusion matrix? So why confusion matrix? It, so for example, if you develop a model which have to classify two scenarios, either that candidate is a male or a female. Let's take this scenario. The model have to predict if the candidate is male or female based on different features it was trained on. So in that scenario, to evaluate the model, we use a metric called confusion matrix, and this helps us to understand how well the model is performing with each and every individual class. So, and it's available with the sklearn library, which is particularly useful for machine learning tasks. So how this so how this confusion matrix looks. So this is how it looks. When you import the method of confusion matrix from sklearn and give that method the necessary parameters, you'll get the count in this format. But in order to know what is the count of true negatives and true positives, all these things you have to know, it's important to know where they are present exactly in this matrix. So this is a very standard format of confusion matrix from sklearn. Let me explain you what is this true negatives, false positives and true positives. True positives is something like the if there is true initially, it means that the model is predicted that in a correct way. So true positive is the model predicted the value correctly, and the model predicted it as positive, and it's also true. And coming to true negative, the model predicted a negative case correctly, and in case of false positive, the model predicted a case as positive but it is false. So I'm making this very simple terms to make you understand it. And the final thing is false negative. False negative means the model predicted that scenario as a negative case, but that is false. So these are the meanings of the terms used in confusion matrix. And then I want to give you a real-time example. For example, let's see this case one where we have a doctor and a patient. Let me cover the true positives and true negatives first, which are very in the diagonal in this matrix. So coming to the true positives, the model predicted the case as positive. It said that this lady is pregnant. So it said a positive thing, and it's also true. So it can be called as true positive. And check the diagonal top bottom. Sorry, on the bottom row right side. So this is a true negative case. It means the model predicted negative. Negative. It means that it said not pregnant. Negative is not pregnant, and that is also true here. So that is called as true negative. And if you check the false positive case, which is on the top right, model predicted the case as positive. It means that the model said it's pregnant, and that is false. So it can be called as false positive. And if you check in the bottom left side, which is false negative scenario, the model said the case is negative. It means it said it's not pregnant, and which is also false. So it can be called as false negative. And the other real time example, I want you to check this case. It will be very much understandable since I explained you one case. But the very important thing to keep in mind is when you watch a confusion matrix, the diagonal values are true positives and true negatives, which means that is the count where your model predicted correctly. So one more point I just want to add here is, as I said you, this confusion matrix is used to evaluate a model which is built for classification related tasks. So when you have a classification model, you can directly calculate the accuracy of a model using accuracy method, which is directly from SQL library. And the second way is you have to check the confusion matrix, and the remaining ways you must go through is you have to check the F1 score, precision, and recall as well. So in order to check this F1 score, precision, and recall, these three accuracy metrics depend on this confusion matrix. So it's very important to know the confusion matrix for while you're evaluating a classification model. So, but what I did till this slide is I just explained you a classification scenario where you have only two classes, either pregnant or not pregnant, or else it's orange or not orange. So, or male or female. So these are only, we have only two classes here. So you know the format of how confusion matrix looks. So this is how the confusion matrix looks. If the model have only two different classes, but what if it have more than two classes? For example, if you are given an image and you want the model to predict if it's a bike, if it's a cycle, or if it's a car. So you have three scenarios here. In that case also, the confusion matrix is useful. And the format of confusion matrix for binary classification looks like this one, and for multi classification looks like this. So these are the true scenarios. The diagonal values are true scenarios, which means the model predicted these correctly. 227 records were predicted correctly for code 19 class. And so that's it. It's used in a confusion matrix is a table used in machine learning to evaluate the performance of a classification model. It shows you the count of the correct and wrong, incorrect predictions of each and every class particularly. And it is useful to calculate further metrics like precision, recall, and F1 score. So that's it, guys. That's it for this video. I hope you understood the confusion matrix well, and I covered you the very basics and the beginner knowledge of this concept today. So if you have any further doubts on this concept, just let me know in the comments, and thank yous. Bye bye. See you in the next video.